What's that? 225. All right, so yep. So what we're doing right now is we are filling in what's called the unit circle. Why do we call this a unit circle? Well, a unit circle is basically just a circle with the radius of 1. Okay? Now, the circle itself isn't necessarily that important. What we're really looking at is just the angle measurements. Okay? So, here we got 0, 90, 180, 245. What's this 45 down here going to be? 315. Okay? And then, now it looks like you cut this in half, but you really didn't. This was actually going to be 30 degrees. So it's not really cut in half. If that's 30 degrees, what do you think that one over here is going to be? No. Go 30 back up. Well, it's got to be between 135 and 180, so it can't be 120. Yeah. What do you think this one's going to be? 210. And then this one back over here. If that's 30, go 30 back this way. 330. Okay. We got 30, we got 45. What do you think we're going to put on this one? Yep, 60. And if that's 60, what's this missing one over here? 120. And then what's the missing one down here? 240. And there's one more we need. 300. All right. I can promise you, by the end of the year, you are going to be so sick and tired of all of these angles because basically you're going to have to memorize them. And we're going to use them over and over and over and over and over and over and over. I'll teach you all kinds of easy ways to memorize them, though. It's not that hard. Okay? Now, this is the unit circle. We're going to use this unit circle today to talk about yesterday we talked about 2 different ways of dealing with like very precise angles, right? We talked about degree decimal. We also talked about degree minute seconds, right? So today what I want to talk about next is a completely different way to measure angles. A whole different system. And those are radians. If you really think about degrees, if you really think about before any angle was ever measured, right? You go, all right, I need a system of measuring angles. Awesome. Let's take a circle and let's divide it up into a bunch of little tiny angles. How many little tiny angles did they break that up into? 360. If you were starting a unit, would you pick 360 as your number to divide by? Doesn't that seem very arbitrary? Now, the reason it actually is those darn Babylonians, like they use that base 60 number system. So 60s, 360 ends up being a nice number for that. But that's why we have that in there. That really seems like a very poor way of measuring angles, if you really think about it, right? So we have these radians. And what a radian is, here's the easiest way to think about it. Instead of thinking about an angle in terms of how far it opens, right? Instead, if we take that angle, that was a pretty good circle. That was pretty good. And you inscribe it in a circle, going to the center point. Okay? Now, as soon as you do that, and you would do it in the unit circle, which means the radius is 1. 1 inch, 1 foot, 1 whatever you want it to be, but it's a radius of 1. As soon as you do that, instead of talking about how far the angle opens, What we can now talk about is the length of the arc that it creates. And we can turn an angle measurement into an actual distance. Does that make sense? Now, 1 radian, if you take this radius and you go 1, the same distance, along the circle, the angle that that creates, that's going to be 1 radian. Does that make sense? Now, that's not as important as how do we use these radians. So basically what we have to be able to do is figure out what all these angles are in radian measurements. Okay? So let's do this. Let's take the easiest one. What is the measure of that angle right there? 360 degrees, right? Now, we got to convert that into radians. Well, we basically have to find the distance now all the way around the circle. We have a name for that. It's called circumference. We even have a formula for that, don't we? What's the formula for circumference? 2 pi r. So 2 times pi times r. Well, what's my radius? No, what's my radius of my unit circle? 1. So it's going to be 360 degrees is actually equal to 2 pi. That is a radian measurement. Now, yes, the actual distance, if you took 3.14 and times it by 2, you'd get like 6.28. We typically don't deal with radians in decimal form, although I'll talk about that in a minute because the SAT really irritated me 2 years ago, and I'll talk about that in a little bit, but don't worry about it. All right, so go back to your unit circle. On here, 360 degrees is the same thing as 2 pi. If I ask you what 1 full circle is in degrees, you're always going to say 360 degrees. If I ask you what 1 full circle is in radians, 2 pi. Simple enough? Now, if 360 degrees is equal to 2 pi, what's 180 degrees going to be? It's 1 pi. 180 degrees is equal to 1 pi. What that basically means is if you take a circle with a radius of 1 and you measure the length of the arc that it creates, it'll be 3.14159, like that's going to be the length. Okay? All right. Well, if that's pi, what's 90 degrees going to be? What? Half pi, or pi over 2. We write all radians in fraction form. Yes. Some of you don't like fractions. I don't know why you don't like fractions. The reason we have fractions is literally because they make your life easier. Decimals are awful to deal with. Fractions are easy. We can handle those. But yes, in this class, I'm going to expect, and you're going to have to from time to time, add fractions and multiply fractions and all that fun stuff. And yeah, it can't be a hindrance to you. All right, so if 90 degrees is pi over 2, and 180 degrees is 1 pi, what's 270 got to be? Pi and a half? Now, we never use mixed numbers. We use impropers. This is going to be 3 pi over 2. Simple enough? Okay. If 90 degrees is pi over 2, what's 45 degrees got to be? Pi over 4. Because it's half of pi over 2, right? Now, here's the easiest way to think about these. Think in terms of fractions. That's a quarter pi. 2 quarters would be here. So what do you think 135 is? 3 quarters. 4 quarters, well, that'd be 1. So what do you think 225 is? What? Which is 5 quarters. Again, we never ever use mixed numbers. We're never going to say 1 1/4 pi. We just say 5/4 pi. 6/4 reduces to 3/2. What's this going to be? 7/4. And then 8/4 will be back to 360. All right. 30 degrees. If 180 is 1 pi, how could I turn 180 into a 30? Divide it by what? 6? So what do you think 30 is? Pi over 6. Now, count by 30s. 1/6. What's this going to be? If this is 1/6, what's 60 got to be? 2/6, which is pi over 3. And then 3/6. So 1/6, 2/6, 3/6. This is going to be 4/6 or 2 pi over 3. What's this one going to be? 5 pi over 6. So 150 is 5 pi over 6. This is 6/6. What's 210 going to be? What? 7/6, right? So that's 7/6. If I go another 30 degrees down to 240, I'll be at what? If this is 7/6, this is going to be 8/6, which what's 8/6 reduced to? 4/3. 9/6 would be 270. What's 300 going to be? 10/6 or 5 pi over 3. And then the last one, what's 330 going to be? 11/6. Now, if I told you right now that in the near future you are going to take a quiz, a non-calculator quiz, and basically everything on here is going to be fair game for that quiz, you'd probably go, whoa, I thought this class was getting easy, but now it's just looking like it's getting real hard. It looks hard right now because it's a lot to throw at you in one time. But I will show you how I got all those, and I will show you how easy this really is, okay? Now, there's basically two things we have to be able to do. These are what we call our special angles. We use these special angles because these are the common angles. Think back to geometry. What were the most common angle? Like what was when we were solving triangles, what triangles did we have shortcuts for? But what right triangles did we have? Did we create shortcuts to solve? That's one of them, but what's the name? What did we call that? We called it by its angles. Do these numbers look familiar? What kind of shortcuts did we create in geometry? Didn't we have a 45, 45, 90 triangle shortcut? Didn't we have a 30, 60, 90 shortcut? Why? Why did we have those shortcuts in geometry? Because those were the most common angles, right? These are going to be the common angles. These are the ones that we're going to use all the time. Now, do we still have to be able to convert every single angle? Yes. Could we do this for every single angle, 1 degree, 2 degree, 3 degree, 4 degree? Sure. That'd be a really, really big, annoying chart, wouldn't it? So we need just a basic method. So the question becomes, how can I take any angle, like 100 degrees, and then convert that into radians? How do I convert any degree into radians? It is actually a really, really easy task. So, what you do is you take your 100. Okay? Step one, you take your 100. What do all radian measurements need? They need a pi, right? So, what we're going to do is we're going to multiply that by pi. We're also going to, if we times it by pi, aren't we changing the value? So we can't do that. If we're going to multiply it by something, we also have to divide it by something that it's equal to. What degree is pi equal to? 180. So the process is very simple. You multiply it by pi, you divide it by 180 degrees. What you're basically doing here, this becomes a reducing fractions problem. All you do is multiply, put a pi on top, you divide it by 180 degrees. Well, let's see, the zeros would cancel. What's 10 over 18 reduced to? 5 over 9? That is equal to 5 pi over 9. It really is that easy. Give me any number, any degree. What? Let's do one that's, because this is going to be a reducing fractions problem, so I don't want to go super crazy here. What do you got? Tell me a number. 60? 60 degrees. All you do, take that 60, you times it by pi, you divide it by 180, you reduce the fraction. The zeros cancel. What's 6 over 18 reduced to? 1/3. Pi over 3. If I want to do 540 degrees as a radian, you take that 540, you multiply it by pi, you divide it by 180, you reduce the fraction. The zeros would cancel. You can divide both of those by 9, so you get what? 6/3? What's 6/3 reduced to? Wait, no. 6 over 2. What's 6 over 2 reduced to? 3. Yeah? That's not right. 3, what? 3 pi, right? Yes? Now, some people look at these fractions as, oh, man, radians are such a pain in the butt to deal with. Right? Because they're all fractions. But there's some really good parts too. Let's go degrees. Who thinks they're good at math? Like, who's good at arithmetic? Come on, don't get shy. All right, what's one rotation? 360 degrees. What's 2? 720. What's 3? 1080. What's 4? Starting to hurt a little bit, isn't it? What's one rotation in radians? 2 pi. What's 2? 4 pi. What's 3? 6 pi. 8 pi. 10 pi. 12 pi. Like, it's just so much easier. Why is it so much easier? Smaller numbers. 360 degrees by itself is a big number. One time around, you're already at 360. That's huge. But in radians, one time around, you're really only at 2 pi. So it's a lot easier to manage. Yes, smaller numbers ends up meaning you're going to need fractions though too. Okay? All right, if we can go radians to degrees, what do you think we also should be able to do? We should be able to take a radian and put it back into degrees. Now, I'm going to show you the formal way and a shortcut way. Oh, stupid half days. All right, I'll show you that on Monday.